So in this exercise, we'll study the collision and the projectile. Exercise, the question is, a particle A of mass ma equals 0.1 kilogram is launched with a velocity v0 equal 0.3 meter per second. So this we have ma, and then A is launched from here with the speed v0 equals 3 meter per second on a smooth horizontal table. At point O at an instant t0 equal to 0, A enters in a head-on collision with B of mass mb equal to ma initially at rest. So when we have collision, the best thing is to organize our work. And then in this case, we will say that we have ma, we will have mb. معنى ال MA equals 0.1 kilogram ومعنى ال MB equals 0.2 kilogram لأنه هي 2 MA. We have the before and we have the after. Now, the before شو عنا MA, we don't have the before. هيدا V0 is the initial speed here. So I don't have the speed of A just before it collide with B. So this one, now we don't have it. But I have, for the after, we have the A, VA. Now for B, before it was at rest, so this is 0. And the after, I don't have it yet. So we'll leave these things and now we'll read the question, continue reading the question. So we have A moves after the collision with this velocity VA, and the position of B just after the collision is given in the document for knowing that the time interval tau is 0.01 second. So between each two position, 2 points, I have 0.01 second. And the distance between B2 and B5 is 6 centimeter. So part 1.1. Show that A reaches point O with the speed V0 equals 3 meters per second. So I need to show that V at the point O is equal to 3 meters per second. We are studying the system as A and Earth. Now we have to pay attention. I can apply here Newton's second law to verify this, and I can also apply here the conservation of mechanical energy. We have smooth table, so this means there's no friction, which means that ME of the system initially is equals to ME at O. Now, initially, this means here, just at this position, yani when we launched it. So initially, what do I have? I'll put here, we have GPE and KE and equal GPE plus KE. This is point O, this is the initial point. We'll take as reference, so we'll take this one as reference here for the gravitational potential energy. Then in this case, GPE, which is mg times z, the height is 0. So in both cases, this will be 0. We still have KE, so it's half MA. V initial, the initial speed is V0 is given at 3 meters per second. So equals to half MA, V at the point O squared. This is what we have to verify, okay? So half MA and half MA means we get that V at the point O here is equal to V0 when it's initially launched. So this means it's equal to 3 meters per second. This means this is the speed of A just before colliding with B. So now عندي هون before I have it, it's equal to 3 meters per second. So sorry, tidy given. Now, part 1.21, okay, using document 4, show that after collision, the motion of B is uniform. So 1.21. If I notice here in the figure, I will notice that the distances between two consecutive points is the same during the same interval of time is the same, which means that the nature of motion or the motion is uniform. So since the distance between two consecutive points remains the same during equal interval of time. During equal interval of times, this means the motion is uniform. And بما أنه عرفنا إنه the motion is uniform, then now the question is find the speed, verify that the speed VB equal to meter per second. Now, بمجرد ما we know that the motion it's a uniform motion. This means I can apply V equal to the distance over the duration, or this means the displacement over the duration of time. Now نحن معنا إنه between B2 and B5, okay, it's 6 centimeter. And this is for how many tau? This is for 3 tau. So then here I have 6 times 10 to the power negative 2, then in centimeter, over 3 tau. But we have tau is equal to 0.01. This is simplified, then we get 2 meter per second. هيدا بيعني إنه just after the collision صار معي ال VB equal 2 meter per second. So صار في كمان إجي أحطها هون. So I have here VB equal 2 meter per second. If I notice here, before and after, we still have only one unknown, which is VA, يعني V of A just after the collision. Now, what's the question? Part 1.3, then prove that VA equal negative 1 meter per second. We know that we have collision. We have a head-on collision. This means that the linear momentum is conserved. When I say the linear momentum is conserved, this means that P before equals to P after, and this is for the system that we're studying. So we're studying the system A and B together. So we have P before is equals to P after. So what do we have before? For the before, can my PA, so here I put PA, but for B can 0, it was at rest. For the after, also I will name it, for example, P prime A, and I will name it here PB. Okay, so before what do I have? I have MA V0. And for the after, I have MA VA plus MB VB. And now we can substitute. Our aim is to find VA. And since I'm working with collinear velocities, they're on the same line, then I can put it in this way. I'll have 0 equals to MA VA plus MB VB, social null vectors. Now we can find, we want to find VA. This is our unknown here. So we can now substitute the values. So we have MA, it's equals to 0.1 times 3 equal to 0.1 times VA. You have to find it. And here it's 0.2 times 2. So we'll get as answer VA equal negative 1 meter per second. This means that A is moving now after the collision in the opposite direction of the x-axis. Now, part 1.4, specify whether the collision is elastic or not elastic. In order to know if it's elastic or not, so we have to find KE before and KE after. For the KE before, so also the system is A and B together. So for the KE before, we have KEA plus KEB. But B was at rest, so this is 0. So we still have MA V0 square. And we get as answer 0.45 joules. Now for the KE after, we have also KEA plus KEB. Now, KEA is equal half MA VA square, and KEB half MB VB square. So we can put the values, we have everything. So it's half 0.1 times 1 square. So we take the magnitude here, okay? Plus half 0.2 times 2 square. And the answer will be 0.45 joules. We notice that KE before is equals, so KE before is equals to KE after, which means that it's an elastic collision. Next part, assuming that the duration of the collision is this much, determine the force done by A on B. We have to pay attention. In order to find the forces, we have to draw the system. So this is, I'm using, this is A, and this is B just during the collision. Okay, now, the question, the part 151, we have to find both the forces. So first we'll find the force done by A on B, which means that our system now is done on B. So our system is B. So I have to trace all the forces done on B, and then we will apply Newton's second law. So we have WB, we have normal B, and we have the force applied by A on B. Now, this is the x-axis. Now, this force is an external force that is done by A, and A is out of the system. So this is why we have to put to name what is the system that we are studying here. So now we can apply, so applying Newton's second law. So we'll have the summation of the external forces equals to delta P over delta T. And pay attention, this is delta P for B, for the system B. Then I can substitute here what we have as forces. We have WB, we have normal B, we have the force done by A on B. Delta P, this means P final minus P initial. So this means P after collision minus P before collision for B only. And over delta T, so don't forget, I'm taking only the system B. Now there's no motion on the vertical, which means that WB and NB will be equal to 0, and we'll still have FA on B. I'll take it in vector. So here also I'll take it in vector. P before the collision for B is 0. P after the collision, it's M times V. So it's MB times VB over delta T, which is equal to 0.2 times 2I. We're taking it as vector, don't forget. And over 0.05. So we'll get as answer for I. Then this will be the force done by A on B. Now we continue. We have to find the force done by B on A. So we're studying the system A now. So come in, we'll represent the forces. So what do we have as forces? We have WA, we have NA also, and the force done by B on A. So come in, we'll apply another time Newton's second law, but this time we have to pay attention. Come in, I have to take the system, only one system, which is the system A. We're studying now A. So we have WA, normal A, and the force done by B on A equal. When I say delta, also P final minus P initial means P after minus P before, and this is only for A. So there's no motion on the vertical, which means I'm only working on the horizontal. But I will keep the vector. So WNN is 0, so I'll keep it like this. Now pay attention here. When I want to put P after, it's M times V. But the P after, so it's 0.1 M times VA, and VA, it's -1I. It's opposite, it's moving in the opposite direction. Initially, it was 0.1 times 3I, and all over 0.05. So هيطلع عنا as answer, here it's -4I. Now, we continue, show that the principle of interaction is verified. We notice here, so this is 1.52, we have the force done by A on B is equal negative the force done by B on A. We have same magnitude, opposite direction, which means that the principle of interaction is verified. Now, let's continue to the last part. B now leaves the table from point B5 taken as new origin of axis. So now we have to pay attention. We have, this is the x-axis, this is the x-axis, this is the y-axis, and we have here is the origin. So the object started from here, and it started from here with the speed VB, velocity VB. So this was the velocity VB, which is نحن كان طلعت معنا it's 2, which means it's 2I. If I wanted to write in this form, then it's 2I. And from a height 80 centimeter above the ground. So with an initial at t equal to 0 and moves in the vertical plane, it reaches the ground at the point H. There's no air resistance, and take a G equal 10 meter per second square. So here, before doing anything, since I know that this is a projectile, then I have to pay attention. Always, we're gonna start with the initial conditions. We're gonna start to do and to write the initial conditions. When I say initial conditions, this means I need x0, y0, and I need to put v0x and v0y. Now, we notice that the object starts from here. So it starts from the origin. and the origin where the x is 0 and the y is 0. Usually we say v cosine alpha and v0 sine alpha. Okay, let's look now at the v. This is v0, هي vb. So it started from here. So we notice that there's no angle between v and the x-axis. ما في عندي angle, which means the angle is 0. So here I can say that v0x is v0 cosine 0, which is 2 times 1. And v0y, it's 0, which is correct. Look here. VB, it's 2i, there's no j. So I only have Vx. So هي هلا لما حطينا initial condition now, we can continue and solve the rest. Okay? So هودي على طول, we have to put them first. Now, the question is, applying a Newton's second law on B, determine the horizontal component Px and Py of the linear momentum. So we have the methods. We'll take the system, we're studying the system B. So by applying a Newton's second law, I will say that the sum of the external forces acting on B equal dP over dt. Now, we have here projectile. This means that the only force acting on the object is its weight. So we have weight of B يعني equal dP over dt. Now, we want to find Px and Py. So we'll do projection along x, another projection now along y. Now, weight with respect to the x-axis is perpendicular, so it will become 0 here equal dpx over dt. We'll do an antiderivative both sides. يعني كأنه, then in this case, I'll take px equal. The antiderivative of 0 dt is a constant. And the constant here will be the initial of the variable. So this is px. The constant is always the initial of the variable, p, 0x. I can continue. It's mv0x. We have the mass is equal 0.2. v0x هيها. So لازم هون نكون مطلعين كاتبينهم قبل. So equals to 0.4 kilogram meter per second. Now we have to use now along y. Now pay attention here. When I want to do the projection along the y-axis, it's a parallel but same direction and not opposite direction. So بما إنه it's same direction يعني it's plus. So I will put plus mg equal dpy over dt. This means that 0.2 times 10, so it's 2 dt cross multiplication equal dpy. We'll do antiderivative both sides. So the antiderivative of 2 will become 2t plus a constant. This constant is the initial of the variable. So p0y and p0y here mv0y. Now look at v0y, it's 0. So this is 0. So you have to pay attention. These initial conditions, you have to put them first. And then I can get at the end py equal 2t. And this will be the answer of part 2.1. Now, let's continue part 2.2. Deduce the horizontal component Vx and Vy. So we want to find Vx and Vy. بما أنه we have Px equal to 0.4. نحن بنعرف إنه Px is mv. So it's mvx. And we have the mass. So we'll get Vex equal to 0.4 over 0.2. So it's equals to 2. In the same way, I have Py equal to t. So this is mvy equals to 2t. And then I have to find Vy. So Vy equal 2 over 0.2 the mass. So هيطلع عندي 10t. So هيك طلعنا Vx and Vy. Now let's continue. Determine the parametric equation. When I say parametric equation, يعني I need to find y. هي هون بده بس y. Now ممكن يسألني x and y. Here we only need to find y. In order to find y, we know that the parametric equation means I'm talking about position. So the position is, in order to find the position, I would do an antiderivative for the speed. So I know that Vy equals to طلعت معنا 10t. In order then to find y, I would do an antiderivative for 10t dt. So بعمل antiderivative. This means that y equal 10t squared over 2 plus a constant. It's y, so the constant will be the initial of the variable, y0. وكنا عرفنا إنه ال y0 هي 0. These are the initial conditions. So this is 0. So I get at the end y equal 5t squared. And this would be the parametric equation. Deduce the time needed for B to reach the point H. Now we have to pay attention in order to find the time. هلا سمعنا كل شيء. We have all the equations. So we need an equation where we have time and we have to reach the point H. طب بيجي بتطلع على H. What do I have? شو عطيني given على H? I have the height. والheight يعني مع Y. When I say height here, this means Y. So I'll put here that I have the height is equal to 80 centimeter, which means that the Y is 80 centimeter. ليه مش negative مع إنه هي تحت؟ Why it's not negative؟ لأنه أنا اخدين ال Y axis positive لتحت. Okay? So this means if I put here a point here, this is the point H, this is positive لأنه it's with the Y axis. So in this case, I can say that, which is equal to 0.8 meter. So صار في عمل substitution. We have Y equal 5t squared. So Y of the point H is 0.85. And I want to find the time. So t squared equals 0.8 over 5. And then we'll get the answer. So we'll do a radical. So هيطلع معنا time equals 0.16. So the time equals 0.4 second. Now, the last part is determine the speed B at the point H. Now, لازم ننتبه لهون. When I say the speed B, okay, so we have to pay attention that we're talking about not only Vx, not only Vy, but we're talking about all the speed. When I say all the speed, يعني بيطلع magnitude. So this means in this case, we will get V at the point H equal radical Vx squared plus Vy squared. So I have to find Vx and I have to find Vy. So we have Vx equals and Vy equal. Vx كنا طلعناها قبل. It's 2. And we have Vy كمان طلعناها قبل. It's 10t. But which time should I take? I will take the time needed to reach the point H, which is طلعت معنا 0.4 seconds. So it's equals to 10 times 0.4, so equal 4. This is meter per second, meter per second. هلا صار في يطلع ال V كلها. So I would say now here it's radical 2 square plus 4 square. So it's equal radical 4 plus 16, يعني equal radical 20 meter per second. And this will be the speed at the point H.